But we are going to focus primarily on hair because of the fact that hair is found many times at a crime scene. We're going to go over the different structures of hair, different parts to it, like what parts are valuable for individual versus class characteristics, things like that, of that nature. Okay, hair, of course, is found in all sorts of crime scenes. It is not possible to individualize hair, so you cannot match a hair to a person. Okay, you can say it's consistent with that person's hair or inconsistent, but you can't match it. Okay, just by looking at it, just because you have blonde hair, curly hair, what have you, it may match, but it's not an individual characteristic. Now, sometimes you can get DNA from it, but you can't always get DNA from hair. It's very difficult, actually, to get DNA from the hair. Okay? However, it can still be circumstantial evidence to help link somebody or something to a crime. If you can say it's consistent with the hair or inconsistent with that hair being found at the crime scene. So morphology is just a fancy word for shape or structure. And so hair is actually part of your skin. It's considered an appendage, which means something that's coming out from the skin. And it goes all the way from the bulb, and we're going to talk about the different phases of hair and stuff. I've got pictures in just a moment. It's going to go all the way from the bulb or the root of the hair to the end of the hair follicle. Okay? And the shaft, which is like the bulk of the hair, has three parts. I do want you to know these three parts. That's the cuticle, the cortex, and the medulla. Okay? And so that's what you typically see whenever we look under the microscope later on today. We're going to be looking at the cuticle, the cortex, and the medulla. So that's like if you slice the hair in half lengthwise, those are the three parts that you'd be able to see. Okay, so I'm going to blow this up. I do want you to know the parts to the hair. And so if you remember when we talked about the skin, we had that dermal, there was the epidermis and the dermal papillary. Well, that's similar here. So this is the capillary, which is the blood vessel, because your hair does require blood, nutrients. And so this is a very, very tiny blood vessel that goes and feeds the hair for if you have healthy hair. Then, of course, we have our papillary layer here, and then this is the bulb of the hair for the hair root. This would be the shaft, and of course the tip would be where it's been cut at. Oops. So let me move this on over. Here we go. And this is just a colored region, so you can see the bulb of the hair. The hair follicle itself is what is keeping it in place. And that's important later on because of the way the hair is removed. And if you remember when we talked about sexual assault, I remember I said that they had to rip the hair out. They can't cut the hairs whenever they take from the victim and the suspects to rip it out. So we'll find out the reason why for that in a moment. And this is the sebaceous gland. What is the sebaceous gland? Does anyone know what does it do?
Oils.
Secretes oils. Okay, so we have the oils. We also have your sweat glands that are around the hair. And then we have the erector muscle. It's also called the erector pili, which is what causes your hair to stand up on end, which is important actually for you to help regulate your body temperature. Okay, and so there's a little muscle on each of your hairs, and that's what, whenever it contracts, it causes your hairs to stand up. So now this is if we took the shaft of the hair and we took like a guillotine or something and chopped it in half lengthwise. You're going to see the three parts, it's shaking right now from the air conditioning, the three parts that you're going to be able to visualize underneath the microscope. Okay, so the first one is this outermost region, and that's the cuticle. So similar to I know women who get their nails done, they talk about pushing the cuticles down. Your hair has the cuticle too. It's the outer covering or the outer coating of the hair, and it's textured. And we'll talk about the different cuticle patterns that there are, because it depends upon the species, or even different types of hair. Many times there's this part that it's usually a darker line that runs through the middle, and that's called the medulla. And so we're going to find out that the medulla sometimes is absent, sometimes it's present. It can be fragmented, and it can be continuous as well. And then all the other stuff, that's called the cortex. And inside the cortex there may be these little pigments or these little black dots called ovoid bodies. But the cortex itself is for humans, it's the bulk of the hair itself. The cuticle is the outside, the cortex is on the inside, and the medulla, if it's there, is this middle portion. It is the cortex that gives the hair its color, not the medulla. Even if the medulla is dark, that's not what gives the hair its color. It's the cortex. And so when people dye their hair, what they do is, you first have to put in some kind of harsh treatment, because what it does is it puts little holes into the cuticle, so that way the dye can get inside the cortex. Then you put that fixer, the relaxant, in there, and it causes the hair then to relax, and the cuticle will then close back up, and the dye is stuck inside the cortex. And that's how you dye your hair. But the normal coloring of your hair also comes from that cortex, so we have pigments in there. And as you age, of course, then you lose the ability to make those pigments, and that's why your hair turns gray or white. It's also, if you prematurely gray, it can be a sign, by the way, of heart problems. And so now you're probably going to be looking in the mirrors, looking for this little gray. But I had an uncle who actually ended up dying, had a massive heart attack, never had any known heart problems before. It was one of my grandparents started on a riding lawnmower, just fell over dead. He was dead by the time he hit the ground. He was completely white-headed by the age of 25. So he was dead at the age around 40. Yeah, and he was really healthy otherwise. He ran, he was very active. But it's not, just because you have premature gray doesn't necessarily mean you're going to have heart problems. It's just one possibility because of mitochondrial damage. Okay, but once again, it's the cortex. It's this cortex that gives the hair its color. The cuticle is the outer covering. It's like the sheath. It gives the hair the strength. And then we're going to see the medulla. Which the medulla, there are different patterns that medulla can have. And that can help give an idea on the species, and also to be used as a point of comparison from different species and different individuals sometimes. Okay, so these are just the words of what I've been saying. The cuticle, it is scalar, it does look like it has scales. We're going to go over some of the different patterns in just a moment. And it's very, very useful for being able to tell the difference in species. Because I've got pictures here, and you'll be able to tell. They are a cat hair. The cuticle for a cat hair looks very different than a human's hair. And so we have various hairs from various animals that we can look at in lab. And we also have different types of human hair that we can look at in lab as well later on today. Now, one thing is, by looking at the cuticle, even if you only get a little piece of the hair, not the full hair, you can tell what direction the hair was growing because the scales always point towards the tip. So that's one interesting thing, is you can always tell because they will point towards the tip as it grows. So even if someone cuts their hair, they'll be able to tell one end from the other. So I do want you to know that, there's lots of subcategories, but I want you to be able to know and to explain the rationale behind coronal, petal, mosaic, and wave. And I'll blow this up so that way we can see it a little bit better. What does the word coronal come from? What does it mean? What's a corona? Yeah, but what's the symbol, I do believe, on the corona beer? Or if you speak some of the Latin-based languages, it's also similar to the word in Latin.
It's a crown.
Crown, yeah. And so they look like little crowns. So sometimes they look like, there's that one. And once in a while you'll see ones that look more like, I'm going to attempt to draw. It will look like this. Almost like a palm tree. That would be a coronal pattern. Okay, there are different types of patterns, and those are similar to petals as on a flower. Okay, and so that's why this, well, that would be considered a petal pattern. Didn't mean to write on that one. So this is a petal pattern. No, you just need to know the 4 basic ones I told you about and be able to rationalize between coronal, petal, mosaic, and wave. Okay. And so the wave patterns will look like waves. So that's the wave look. You can have different irregular versus regular waves, all that kind of stuff.
Do we need to know subcategories?
Nope, just be able to explain the 4 broad basics. And if I gave you a hair, you could use and say, well, I think it's, mosaic because of this, or petal because of this, coronal, or wave. Okay. So chevrons, what do you think is, so since it is a subcategory, but a chevron, what is a chevron besides a gas station?
Is it a triangle?
It's a what?
They have a symbol. I mean, it's like half.
To me, it always looks like the EKG. The EKG thing. That's what that. It's a type of wave. It's this little. I can't explain it either way. So that's a double chevron. A single chevron would just be like a really big wave. So, like if you were looking at, if I had given you this one on a quiz or an exam, I would expect you to say that's a wave because it's clearly not a crown. It's not mosaic, which we'll talk about mosaic in just a moment, and it doesn't look like a petal, so therefore it has to be a wave. What is mosaic when we say a mosaic? You hear about mosaic as a mosaic pattern or something like that. Right, they're pieces that fit together, it's like a jigsaw puzzle. And so that's why this one is called irregular, because of the fact that these are irregular pieces, but they all fit together. Whereas if I gave you this one and you told me it was some type of mosaic, I could, as long as you explain the reason why, I could understand. The difference between irregular and regular, it's kind of hard, in the sense that the pieces that come together from the mosaic here are more similar in size versus big dissimilarity. But once again, a mosaic is a mosaic. So if you look at this one, this is pectinate, which is a subcategory. But of the 4 major ones, what would you call this one? Would this one be a petal, coronal, wave, or mosaic? And so I would expect you to be, because you can make either of those arguments as long as you explain the reasons why.
Which one would that be?
I would have accepted either petal or wave as long as you explain the reasons why. Because there is a wave action, but at the same time, this does kind of look like a sunflower. Now let me move this up so we can see some more. So I'm hoping that you can see. I didn't want to give away all the answers. Whereas if we look at this one, what would this one be most likely? Pardon? Here, let me. This one right here. Whoa. This one right here is going to be a petal. Whereas this is clearly a wave. I would take a wave for this one. That's a single chevron versus a double. And then this one is a wave. It's a mess, but it's a wave. No, not that I know of. No, I think that pretty much it's usually species specific, and I've got examples from different animals and things like that coming up. Which you shouldn't, realize that if you, even within the same species, like 2 different dogs, some dogs have really smooth hair, like almost like human hair, and then some of them have very coarse hair, and a lot of that's due to the cuticle. And also on the same body, you can have different types of hair. But that's true with our bodies too. Body hair versus the hair on top of your head is very different. Okay, so this one, I'm going to actually turn all the lights off so you can see some of the patterns better. This one's from a deer. Okay, so that's the cuticle. A lot of times, the way that you can see, it's kind of hard to see the cuticle. And to differentiate it from the medulla, which I'll show you what the medulla and the cortex look like in just a moment. But what they've done sometimes is they'll take a hair and they'll put something like almost like a jelly or glue, and they will like leave a little finger, it's not a fingerprint, it's a hair print, but they'll dip the hair in it and they'll carefully remove the hair, and that leaves behind the cast, the mold. And so then you can clearly see the cuticle and not have to worry about anything else. And so I'm not sure if this is the actual cast made from it, but or if it's the hair itself. So what kind of the four big ones, mosaic, wave, petal, and coronal, what kind do you think is this one is most like? I would say probably the petal, but now if you explain mosaics, quite possibly this is clearly not coronal or wave. Like if you said that would completely be wrong. But yeah, it's very petal-like. Okay, or if you'd explained like how you thought it was a mosaic, I can understand that. But that's a deer. This one, I forgot to write down what it was. But this one's a different animal. And so what kind of cuticle is it? Pardon? I would say this one's probably more mosaic. One of these was from a skunk. Maybe I just do it right down. What about this one? Wave. This one's clearly a wave. Kind of looks like a zebra almost. It's not. This is not zebra hair though, but yeah, this one's clearly a wave. What about this? Yeah, this one looks like a mosaic or some type of really irregular wave, maybe, but yeah. Here we go. This one's very much coronal. These are two different cats. Okay. Now what they've done is it's false coloring just so that way you can see them. Just to let you know that this is, the cat clearly was not colored like this. But what about all this other stuff that's stuck in there? Yeah, it's gonna be dander or dirt. Could even be, insects or something like that. But yeah, there's dander and dirt and oils and other stuff that you can see many times with the microscope. Yeah, this cat definitely could use a good bath. Okay, so those were the cuticles. Now we're going to talk about the cortex, and that's the bulk, the main body portion of the hair shaft. Okay. And its major implication or importance is the fact that that's where the pigment is. So that's what, once again, gives the hair its normal color. And it's the distribution, the shape of these that you can use for comparison between different individuals. So yes, maybe two of them are red hairs, but the pigmentation is distributed differently between one hair and another hair to make it either consistent or inconsistent with the suspect or the victim or what have you. And we've already talked that you could use the cuticle to say, okay, this is clearly not a human hair, this is a cat hair or a dog hair. Which I used to have some examples of hairs from my dogs that I had brought in, but I think the previous years have lost them since. And this is the medulla, and it's like a column that runs through that center part, but not every hair has a medulla. And that, whenever it's not there, it's called absent, an absent medulla. And there is a formula, it's a very, 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 very simple formula that I do want you to know. It's called the Medullary Index, and I've got it written out in a moment. But it's just like what percentage or what fraction of the hair, the diameter of the hair, is made up of the medulla. For some people and animals, it's either gone or it's very tiny. For others, it's almost the entire shaft. Okay, so usually for humans, we're talking about very small amount, if any. Okay, whereas some animals, it's almost the entire diameter. That's the medulla. And there are different medullary patterns too. But the four that I want you to know are continuous, which what do you suppose a continuous medulla looks like? It's a straight line. There's interrupted, which means it would be a straight line, but it's broken in a couple places. And I've got pictures in a moment. There's fragmented, which means it's broken repeatedly, like it's been fragmented. And then there's absent, which means it's not there at all. And this can vary from person to person, from hair to hair, parts of a body, all this kind of thing. And especially some of the animal medulla, and the plural for medulla is medullae. But some animals have really cool ones. They look kind of like pearls or bubbles and things like that. But human medullae it's not very pretty. It's just a streak. So here we go. Alright, so this would be the medulla, and would you suppose that this one is going to be continuous, absent, fragmented, or interrupted? That one's continuous. What about in this hair? Absent, and then this one? I would take either one, because it's kind of hard to tell, because it's a little broken here, and it's definitely broken there, so fragmented makes the most sense. But if you had more of the hair, to where you could see that these were the only two breaks, essentially, then it could be interrupted. And that probably will not let me click through. Let's see. I don't know if that. Let me just check real quick. Now, I've also included not only where they come from, but their magnification. So, for example, the rabbit has been magnified 250 times, whereas the human has only been magnified 70. Okay, so this, on the rabbit, you can see it's got a very distinctive patterning for the medulla. It kind of look like little ladders or little tracks or something. Whereas on the human, what kind of medulla do you suppose that this hair, let me just write in. Right there is showing. This one's fragmented. I mean, there's just little bits and pieces here and there, whereas the other three, at least in the view that we see, you don't see any medulla, so they would be absent. Okay. So this is the skunk, both the dark and the white hairs, and it's kind of hard to tell, but they almost look like little pearls or something, little jewels in the white portion. And then the black hair, the dark hair, it's more of a ladder-like. This is a tiger. Okay. First off, this one's really cool because we can clearly see all three parts: the cuticle, the cortex, and the medulla. Okay. So, first off, let's just look at the cuticle. What kind of cuticle pattern is that? It's coronal. Almost looks like a little stack of cups or something. Right? And then we can see the cuticle itself, which is all this other stuff that's on the inside. And then we have the medulla. What kind of medulla would this one be? This one's a continuous medulla. This is a mouse hair. So it's got a very distinctive pattern for its medulla versus the human. And so the medullary index for a mouse is quite high, because the way that you do determine the medullary index is you literally measure just the diameter of the medulla divided by the total diameter. That's why I say it's really simple. And this one would be almost 1, because it almost takes up the entire length. Whereas the human one that we've seen in the past, if it's there, it's really tiny. Here's the squirrel. First of all, this one right here, that's just a bubble. But that's the squirrel's medulla. I like the cat of unknown origin. But it's definitely got a fragmented or interrupted medulla on this one. So yeah, the medullary index is the diameter of the medulla, and you just divide it by the diameter of the entire hair. So it's always going to be less than or equal to 1. And for humans, it's usually less than 1/3, if it's even there. Obviously, if it's absent, then the medullary index would be 0, because 0 divided by anything is 0. Some of the animals, like the mouse one that we just saw, it's really, really high. It's almost 1. Okay, so that's another way you can kind of get an idea of whether or not the hair is of human origin or of another species, which that could still be circumstantial evidence. For example, if you found hairs consistent with my dogs at a crime scene, then that could be used circumstantially as transference from myself to that crime scene. Okay, are there any questions on the parts? And one thing that, let me just go. Okay, and so the root is the part of the hair that's inside the follicle itself, and it has everything there for the hair to grow, okay, for it to be healthy. Now, I'm sure that there have been times that you've been brushing your hair or combing your hair, or maybe you've gotten in a fight or had some that ripped out, and there'd be that little white portion that's on the very end. It's kind of white and clear. It's not dandruff, but what it is that's called the follicular tag, and that's very, very important. The follicular tag is the part that will have your nuclear DNA in it. Okay, remember, what's so special about nuclear DNA?
It's for that one person.
It's specific for that one person. Whereas if it doesn't have that follicular tag, it's hard to get any DNA from the hair, but the only DNA you'll be able to get from the hair is some mitochondrial. You've got to have that follicular tag. That's the reason why whenever they're doing a perk kit for sexual assault, and I know it sounds horrible, but they're going to rip the pubic hairs and the head hairs right out of both of the victim and any suspects, because they're deliberately trying to get the follicular tag. Okay, so they can't cut it, because if you cut it, you're not going to get it, obviously. So they'll just take tweezers, forceps, and they'll rip it out. Okay, and so that's the way you can individualize the hair. By looking at the morphology, the structure, the shape, you can't. You can say it's consistent or inconsistent with it. Or you may be able to get mitochondrial DNA. However, as we know, that will only link it to a certain maternal bloodline and not an individual. And so what we're going to be doing in the lab today is actually using a microscope. Now we have just a traditional microscope. We don't have a comparison microscope. But the comparison microscope is similar to what you do with that ballistics. So if you go ahead and you take that ballistics assignment, quiz online, which I looked at it since I was homesick, I went online and I was able to look through it and get it to work. And so if you go through and get that to work, you're going to be using a virtual online electronic comparison microscope. They do the same thing with the hairs. Just like you match the lands and the grooves on a bullet, you're going to try to match up medulla, the cuticles, things like that, between the hairs to see if they're consistent with it for visual inspection. Okay, so when it says scale structure here, we're talking about the cuticle portion, the medullary index, the shape, and the medulla, things like that. There's the medullary index. Okay, and once again, this is the diameter of the medulla divided by the diameter of the hair shaft. It's always going to be 1 or less than 1. And once again, for humans, it's around 0.3 or less. Some of the animals, it's almost 1, because it takes up almost the entire length of the entire diameter of the hair. Okay. Now, the problem with hair, this is a big limitation, is that it can, even though you're looking at it microscopically, and they like to show pictures, it can be very subjective, right? Because first of all, you've got to find hairs that are very similar to each other. And secondly, you're just going to be basing it off of the scientist's viewpoint of, okay, yes, I found a hair that's missing the medulla, and there's also hair of similar color and cuticle is missing in medulla at the same, on the crime scene. And so once again, it's kind of subjective. So it should not be used, I should say, as the sole piece of evidence to try to convict somebody. It can be circumstantial evidence and say it's consistent with it to help link him or her to the crime scene. But unless you have that follicular tag, it shouldn't be used to individualize that. Are there any questions so far? Okay, I'm going to go ahead and